Hello everyone. In this video tutorial, I will be taking care of a new sensor that is AD7999. And to get more knowledge about this sensor, let's have a look over the website that is controleverything.com. And here we have to search for this sensor. And as you can see, this is our sensor. It's a 4-channel 8, 12 or 10-bit analog to digital converter. And these are some of its more prominent features which you are able to see on my screen. And as a plus point, you can also purchase this sensor from here, right from here. Now for the interfacing purpose, I will be taking care of this sensor AD7999 using a particle photon, and a particle code is required. So for that, let's go to resource tab, and here comes the particle code sample. Now you can download the code sample as a zip file from here, and for that also there is another option. It's github.com, and you can have the code from the repository. There is Control Everything community. Well, we require some hardware, and let's make some connections for that. Well, coming to the hardware connection setup part, the first thing we require, which you are able to see on my screen, is a particle photon. Now this here is an I2C Shield. It's available and can be purchased from the website controleverything.com, and the reason we are using this shield is to make connections easier with other I2C devices. So for that, what we require is to gently place this particle photon over the I2C shield and make a connection just like that. Now to power up this particle photon, what do we require is a micro USB cable, which you can see on my screen, and gently insert it over this power jack. Now we require our sensor, that is analog to digital converter AD7999. And this here is a connecting cable. Now make a connection among the sensor and the cable, and make sure that the brown wire of the cable should be connected to the ground terminal of the sensor, and same goes for the I2C shield. So we are done with all the connections we need for this setup. Now let's have a look over the code and let's interface. Now in the interfacing part, the first step is to log in to github.com, and after that we have to search for the repository, that is Control Everything community. Then here we have to log in and type in the sensor name, and it is AD7999. Then here comes the particle code. But let's have a look over the instructions we need to follow up. As you can see, first of all, we have to log into our particle photon and set up the device according to the steps which are provided on this very link. And as I open up this link, you can see a lot of instructions and a lot of guidelines have been provided to you for the successful installation and connection of this particle photon. Please do it carefully, and after that we have to download the code, and we have to copy the code on the online ID. And build.particle is the online ID where we have to create a new file, then we have to paste the code and then save it just like that. And the last step is to verify and flash the code on the particle photon, and the code output will be displayed in the form of logs at the dashboard. And this here is the dashboard link where we can have our relevant output from the device. So after getting these instructions, we need to get back to a particle code, which is a .in extension file. As you notice in the code, we have two libraries included, which are application.h and spark wiring I2C.h, and the address of the device has been defined as 0x29. Then we have initialized a raw ADC integer, as you can see, and in the void setter function we have set some variables, and we have initialized I2C communication as master along with serial communication in the baud rate equal to 9600. Then we have to start the I2C transmission, and we are going to send some commands. We are going to write some data onto the sensor, which is to select configuration register channel 1 enabled, and it is 0x10, the writing command. Then we have to stop the I2C transmission here. In the void loop function, we are going to request and read 2 bytes of data, which are the raw ADC, MSB and LSB, and after that we are going to convert the data which is according to the guidelines, the information provided in the data sheet for AD7999. At the very end of our code, we have the output data to be displayed onto the serial monitor, which is the raw value of the source, and the string raw ADC will be displayed. So this is how the code looks like. Now let's see how it works. Now we are going to have a look over a very interesting part, that is to check for the working environment. and for that we have to copy this entire particle code as you can see on my screen, and we have to open up the build terminal IDE, and here we have to create a new file. First of all, for that we have to paste the entire code we have just copied, and we have to name it AD7999 for the reference, and then we have to paste it, and then we have to save it. Now to verify and compile the code, this is the step, and it's a great work. And then we have to flash the particle. As you can see, we are flashing the code, and we have to check for the magenta flash, which will confirm that code is good to go. And we have just now see the magenta flash onto the screen, and we have the notification here also. Now we have to look over the dashboard dot particle user logs to have the output onto the screen, and let's open up the user logs, and we have the raw value of the source, a digital value of the analog input, which is, as you can see, exactly 0 because there is nothing connected onto the terminal of the channel 1 and ground terminal. But instead, when I try to connect it with a AA battery of 1.5 volt, as you can see, we have the raw value of the source changes, and it's almost constant. It's the raw value 4950. It's constant already. So this is how the sensor responds. Now the next step is to look over the applications and the benefits of this sensor. AD7999 is a 4-channel 8, 10, 12-bit analog to digital converter. As you can see, it's a low power successive approximation ADC with an I2C compatible interface. Each part operates from a single 2.7 volt to 5.5 volt power supply and features a 1 microsecond conversion time. Due to these features, it is applicable in a lot of applications like system monitoring, battery powered systems, data acquisition, and medical instruments. Well, you can have this sensor and you can purchase it from controleverything.com, and you can get the code from resource tab. From this site, you can download the code as zip file. Also, you can get the code from github.com, and the repository there is Control Everything Community. In the end, I would like to make it clear that if you have any doubt regarding any part of this sensor or video, you can have your queries on controleverything.com, and you can post your comments on the community page on this website. For articles and blogs, you can have a look over on instructables.com, and to subscribe more video tutorials like this, you can have a look over our YouTube channel. In the end, I hope you enjoyed this video and had a good one yourself. Thanks a lot for watching.